Okay, is up.
Feels fine.
Okay.
Feels like you're mine. Feels right. So fine. I'm yours. You're mine. Like paradise.
How do we turn up the audio? Probably use this tab.
Feels fine.
Okay. Okay. Now probably it should be quiet. Probably it should be quiet. Okay. Yeah, it is quiet. Okay. Yeah. Let's go. Okay. Yeah, it is quiet. Okay. Okay. Hi guys. Hi. Hi. Yeah. Welcome to Create Labs. I am your host for today. I'm your developer for today. I'm Tridhatri, and yeah, a little bit about me is basically I am doing an intern at Intel right now, and we're trying to build something from scratch. And the idea came from um trying to figure out how to build a rag from scratch. And the only language I am familiar with is C, and so I think it'll be good. So yeah, the only language I'm familiar with it is C. So try to build a RAG pipeline from scratch in C. And yeah, part of the reason I can just show you the screen. Yeah, okay. Part of the reason is this guy. So this guy streaming, right? Okay, okay, okay. This is the guy who created Redis. So Redis, as you know, is like a key value vector database system. So this is the guy who created Redis, and I was like just stalking his GitHub account one day, and yeah, I landed upon his repositories, and some of the repositories are very good. And for example, this is what we're trying to build a base upon. So this is a repository for a pure C inference for GT small embedding model. So we yeah, so it's a very simple project. Yeah, so this is just one Python file that we have, and rest of it is just C. I think we just have to run once. This command we just have to run once in Python, and the rest of it is C. And the reason to choose C was because I'm considerably, I wouldn't say good, I'm better at C for my capabilities and abilities. So yeah, that's why I try to do it in C. And I think RAG pipeline, a lot of people built it in Python, and Python gives you a very good um, infrastructure for all the libraries. And but yeah, so I'm trying to optimize it in C, which will be a challenge. And it's currently 9:12 p.m. right now. Yeah, that's why I wanted to start off this stream just right now. I wanted to, or else I could wait to for tomorrow. Start off with a 12-hour stream for tomorrow, but I didn't want to wait. So because I just wanted to start. So this will be a part part stream. So this will be part zero, part one. Probably part one will just complete it tomorrow. So yeah, okay, let's do it. Yeah, okay, that's still streaming. Okay, now yeah, I have my terminal here. It's still streaming, right? Okay, fine. Yeah, okay. Um, so I have my terminal here. I basically asked Claude about what we can do and how we can do it. So gave me some advice, gave me some things that I did not like. So I made a decisions.md file. I mean, I completed my chat with Claude right now, and I'm just going through the chat. Um, uh, yeah, like this file decisions.md will encompass all of the decisions I made while planning. So yeah, so this is the decision. So once like in the start I wanted to build just a basic minimal rag and pure C. That was my prompt. No C++ because again I do not I'm not familiar with C++ that much. So yeah, trying to build. So that was the goal. And yeah, again it says the goal is a minimal dependency free portable pipeline. C gives full control over memory, has no runtime overhead, and forces simplicity. The content is aesthetic, small, readable, and self-contained. Is only achievable in C. Yeah, the main inspiration I think was Scientist. This guy. So he has some repositories where I showed you one of his repositories. It's a very STL kind of repository. Not STL. SDB, sorry, SDB. So if you are familiar with SDB repositories where it's just a single file in C, so it's just a single file library that is made by Sean Barrett. I think it's his name. I can show you. Okay, I can show you Sean Barrett. No, SDB library. Okay, what am I doing? SDB library. Yeah, okay, no, I don't know. I do not know his name. STB, yes, STB. Okay, and this is the STB repository. I think it's made by, his name is Sean Barrett. Yep. So all of these are single files. So all of these are STB vorbis.c, xwave, one for image, one for, I think for strings is also there, for text edit, sprintf, dxt, whatever. All of these are just single files, single file libraries. You can just call it in an API form, and you can just start to use it. So pretty much I love this idea, like it's minimal code and it's only single file. I mean, in the current times it's like a lot of code generated by LLMs that you honestly like kind of get bored of. So that's the thing. So this was also my inspiration to do a single file, single file implementation. Probably not a single file, but like 2 3 files or 4 files. That's all the goal is, and using just minimal code, and that's why we're building a minimal rag pipeline. Okay, So with that out of the way, again, I coming to the specific decisions that that me and Claude made, me and Bro made, was again, yeah, why not Python? I don't like Python. And why not DS4? So DS4 was again a repository made by Antares again. Wanted to go for Antares, all of these libraries that are there. So wanted to query his all of his repositories, and yeah, because we considered it, me and Claude. So, but again, it was kind of it was too large for our use case. DeepSeek v4 flash only. This was like a little too large for us, not minimal, and no embedding API exposed in ds4.h. Hidden states exists internally. Yeah, so there's no embedding. That's a real pain. And DeepSeek v4 flash is 12 to 14 GB in Q4, which I do not think I have the capability of running on my local system. I'm using a Mac M1, so I don't think I will be able to run it. And we also consider GGUF tools. This is kind of stupid, but GGUF tools is basically a GGUF is a project, is an org which made llama.cpp, I think, and Antares created some of the tools in C and made it as a library. So this again, it's not needed because we're trying to do a pure C implementation, and it already has done a pure C implementation for it. And llama.cpp, we're just calling it. We're just interacting with it as a server, so we don't really need it. Our C code never touches a GG file directly. That's cool. Useful for inspecting model files, but not a runtime library. Okay. Embedding model GT is small, so we're trying to for some of the embedding models that are there. We landed upon GT small, but previously considered was where all mini LM L6 V2 and Quen 3 ASR 1.7 billion parameter model. But again, I think they performed little lower than GT small, so higher MTB retrieval benchmark scores than all mini LM at similar size. I do not know what MTB is. I do not know that. So yeah, that's the point. Like, I do not know what RAG is. I mean, I just know that it's a vector embedding system, and you do basically a cosine similarity search. Cosine similarity between the existing vectors against the user query, which is converted to vector, and you do a cosine similarity, and whichever has a higher cosine similarity, you just pick that and feed it to the LLM again, and then LLM is generating with that prompt. So yeah, I just know it in English. I don't know how to code it, and I do not know what embedding is. So I do not know what embedding is. Well, I mean, I know what parameters are, and I studied neural networks in my class in my college, but I do not know what embeddings is. So we're trying to first we'll start to understand what embedding is, and then we'll go through again our code, right? So pure C implementation by Andres, okay. Again, so we rejected these two because again the GT small was better in terms of some benchmark that we do not know. We'll find out. And the embedding library, yeah, so this is just a inference library made by Andres. We'll try to not copy his library, or we can copy because currently I don't have much time. So for the first stream, I think at least we can just start off with cloning it and trying to understand it first. It's just 900 lines total, so we can fairly easily understand what it's about. So, and I think yeah, he says Claude says it's BERT transformer. I don't know what BERT transformer is, and word piece tokenizer self attention ffn, mean pooling, L2 normalization. Honestly, I do not know what this means. No idea what any of this means. um, so we'll just bear with it for now, and we'll try to find out what it's about. He has also made Apple accelerator support using this, which seems like a compiler flag. We'll try to do that too. Output matches PyTorch numerically. Okay, that's I do not know what that means again. I literally did not see what the repo is about. I just picked it because I found it interesting just by reading the README. So again, it has 6 function APIs: GT load, GT embed, GT cosine similarity. That's pretty good. It's amazing how he wrote it. Same cell as the rest of the popular. Okay, all right. Known caveats: remediation no accurate testing performed for all tokenized edge cases. Okay, we need to try to look for that. Okay, we'll try to keep that in mind. Okay, so tokenizer ASCII only, not ASCII Unicode falls back to UNK, which is not needed actually, because GT model does not support non-ASCII Unicode, and it only supports English. So for our use case, I think for a minimal drag, I think it's okay, it's fun, and not thread safe. Shared working buffers in context struct. Okay. Okay. I do not know what that means. Model stored as unquantized flow 32. Okay, flow 32 we understand. Unquantized we don't understand. 127 MB and not 33 MB like quantized GGUF. We'll pretend we can understand that. Requires one-time Python conversion model, convert model to Py to produce GT model. That's fine. Okay, assessment caveats or edge cases that do not affect English language RAG. The math is correct, right? Okay, the math is correctly a norm, attention, GALU, softmax, mean pull. We'll try to understand the math also, because I think it'll be interesting. But I don't want to spend too much time in the math, because I think it's maybe it's not needed. I don't know. It's not needed. Right? Come on now. I know. We're building from scratch. And this might not seem building from scratch, but this is the start. This is a literal start. I've been waiting to start a stream since last week. So alternatives considered: small LM2 1.7B, Quen, DeepSeek. Yeah, no, we already went through that. Why we choose GTE? Okay. Oh yeah, sorry, generation model. Okay, this is the generation model. The actual LLM we feed into the after the vector cosine similarity is done, we feed the LLM. That's the LLM we're talking about, which is the tiny llama 1.1 billion, smallest viable chat capable model, 1.1 p parameters, Q4 KMGGUF 670 MB. Do not know what that means. Trained on 3 trillion tokens, good quality for its size. Okay, runs well on M1 via llama.cpp with pedal. Okay, rejected DeepSeek v4 flash. Again, that's how many times will you write Claude runtime? Again, do not know what that means. Why server mode, not direct linking. Llama.cpp C++, not C. Linking against it would break the POC goal. Yeah, okay. We're not directly linking it through the local system. We're using a server mode exposes an OpenAI compatible HTTP API. Okay, RC could calls it via libcul. Okay, clean separation, metal acceleration, and when handled by llama.cpp. That's fine. String library STS. Again we try to again see what antivirus has been doing, and I also came across this library SDS, which is the string library. So dynamic string library is what it says. So again, pure C, zero dependencies, just 2 files, a header file and a C file. That's all it is. Battle tested, used in Redis since 2009. That's great. still maintained. Okay, useful for building HTTP request bodies, accumulating chunk text, STSS, split len for document splitting. Okay, that's cool. SDS cat printer for prompt building. Okay, okay. All right. I think we can. What it's saying is, we can use this library and call its APIs to split a document and also for prompt building. That is interesting, and it's also anti style. That's what we're going for. Okay, that's cool. Yeah, this was interesting because we found it. I found it. I mean, okay, fine. Me and Claude found it through the historical Redis versions repo that IDRS created. So it was, and you can go to his GitHub and see historical Redis versions. Then look at the modern standalone version. That's pretty good. Yeah. So yeah, SDS was the modern version of that. So that's pretty good. And then we have JSON parsing, CJSON. Okay, CJSON again. JSON parsing we can do by CJSON library chose because single header file, again pure C, zero dependency, sufficient for passing lambda.cpp API responses, widely used, well tested. That's cool. HTTP we're using libcurl. Okay, already present macOS, no installation needed, standard reliable C HTTP library, only need for calling the lambda.cpp generation server. That's pretty good. And then for vector storage, 4 versions. Okay, yeah, the 4 versions. Okay, 4 versions that we're doing is first version, right? It gave me to like 3 versions and I asked for the fourth version for myself. But so this the 4 versions are dependent on you can say the vector storage, the actual vector storage. The version 1 is basically the flat binary file, custom binary format. Retrieval is linear scan with GT cosine similarity. We can use that API to linearly scan is what Claude says. Okay, we do not know. 0 dependencies, 100 lines of C, Y viable, 5000 chunks into 384 DIMMs, 7.7 M floats. If you whatever that means, we do not know. And it is dict C. Okay, in memory hash table from historical Redis source. Okay, that's the dictionary. Okay, that's cool. Hash source, and then values the text plus embedding. That's cool. Linear scan for similarity, big O one for lookup by ID stays fully in the Antiris ecosystem. That's pretty cool. And version 3 SQLite vect. So I was pushing Claude for let's make a Redis based RAG pipeline. I do not know what Redis is actually, what RAG is actually. I just know in the surface level. But then Claude said because we're building a minimum RAG, it said it's too heavy and Redis is like not minimal and it has too many files. So it's suggested SQLite plus SQLite vector extension single.c file by this guy. I don't know what. Okay, HE07 017. Okay, thank you, guy. So I think he's some famous guy. HNSW approximate k and index. We don't know about that. Best for 10k plus chunks, persistent index, SQL query queryable. Okay, SQLite 3 is already in macOS, is cool. Version 4 custom vector index. Yep, so we'll go through all of these versions. Okay, all of these versions we'll try to build it in a reasonable amount of time. Right, custom vector index, implement HNSW IVF from scratch. Okay, IVF I've heard about. Think in my distributed system class. Yeah, yes, IVF I've heard about. I don't know about, I mean I forgot, but yes. Okay, cool. Yeah, again, why we rejected some of these things, Redis, rejected because full Redis is too heavy for a minimal local RAG. Again, yeah, Redis vector search requires Redis stack and also network dependence, so it's like a server and client, which we're not looking for doing that. We're just supporting a single client on locally. So rejected that, rejected this, rejected Quen ASR. Don't know about this. ASR, okay. Okay, I was kind of stupid because I did not know Quen 3 ASR was a speech model, so rejected. M platform M1, yeah, platform is M1, yeah, that is what I'm using, so obviously that. And plan.md, we can go to plan.md finally. Okay, this is the plan. How much time has passed? 26 minutes. Damn. Okay. Okay, but this is the plan.md. Plan.md is basically a file made by Claude, prompted by me, which basically means I made it. RAG in pure C. Project plan a minimal retrieval augment generation pipeline written in pure C, targeting Apple M1, no C++, no Python or runtime, no heavy frameworks. These are the goals. Okay, that's what we have discussed. Okay, this is the embedding model that we're using and the generation model we're using. Okay. Okay, I get it. Okay, I get it. I get what embedding is right now. Okay, makes sense. One-time model setup. So we have to pip install Hugging Face Hub safe tensors from download. So basically we have to download the GT small from Hugging Face. Okay, fine. Pip install Hugging Face Hub safe tensors. Okay. Python C. Okay. Okay. Python compile, is it? Okay, that's fine. Okay, convert to GT model. We'll do that. That's cool. Download Tiny Llama. All I think all this is just Antares GT repo readme instructions. That's what we're following. And then we have to download Tiny Llama gguf. Reinstall llama.cpp. That's cool. And Hugging Face CLI. Oh, okay. Okay. Run llama.cpp. We'll try to run this. Okay, that's the server. I still do not know what llama.cpp is, so we'll try to figure that out. Shared libraries, all versions. Yeah, okay. That's cool. Shared source files. Yours, main.c, chunk.c, embed.c, llm.c, or llm.h. Okay, that's cool. Architecture. So okay, this is the actual architecture ingest. So we ingest a text file. Okay, that's interesting. We ingest the text file, generate a chunk.c. Okay, we convert to chunks and then we embed it using this model. Okay, got it. And then we store it in a database using SQLite. Okay, and then query text using embed.c again. We convert to embedding the user input text, and we retrieve top k chunks llm.c answer. Okay, that's pretty that's pretty it's pretty simple. Okay, I mean it looks simple, but do not know how complex it will be. Okay, the version 1, what we're trying to do is flat binary file. Storage is custom flat binary file on disk. Oh, okay, so we're just storing it as a kind of a flat binary file. Okay, and then retrieval brute force linear scan with code sensitive letters. Okay, we'll try to understand complexity as well doing this, so it's cool. Extra files, none, fully self-contained. Okay, binary format, retrieval, load instruction to memory. Okay, sorry. So okay, so retrieval. Okay, this is the version 1. Okay, I'm sorry. Version 1. So it's hard to read MD in any of them. I have this actually. I can do this. I'll open. Okay, that's cool. I'll open an MD file here. Okay, cool. So and this is the version 1 that we're building. So let's focus on version 1 for now. The binary format. Okay, there's the binary format. Okay, it's uint32 and number of chunks. Okay, we're defining that variable. Chunk is 0, uint32, text len, char text, float embeddings 384. Okay, so probably a struct for a chunk, and this is the members of the struct. It's interesting. Okay, and then retrieval is load all chunks into memory. Okay, for each chunk score is equal to gt equals unsimilarity query emb chunk emb 384 return top k by score, and then we'll compile using this cco3 march native fast math. I think this is the compilation method from GT itself. I'm sorry, what am I saying? Okay, it's using Clang. It's not Clang, sorry. Okay, okay. Let's see about that. When to use small document size less than 5,000 chunks, no dependency whatsoever, learning a prototyping. Okay, so let's forget about version 2. Let's focus on version 1. It's fairly simple, I think. You just put it in binary format, and you just do this and convert it into a binary format, and then brute force linear scan with cosine similarity for every chunk. Interesting. That's pretty cool. Okay, let's try to do it. Okay, let's try to do it. Okay. Okay. So okay, there's nothing here. Okay, let's go to Claude. Sorry, let's go to Claude resume. Okay, just 1 second. I'm just checking if the stream is good. Should be good. Once again, I'll just pause the stream. Yes, I'm streaming. Okay, I'll watch it on 38 Labs. Watch it on 38 Labs, bro. You're on stream, by the way. Hi, chat. Okay. Hi, chat. Okay. Okay, bye. Okay, let's start coding version 1. Okay, yeah, we are ready. Yes, ready. Okay, let's go. Let's do. Okay, well, I actually love this um, Claude placeholders for thinking, pollinating. It's just amazing how they came up with the idea. But okay, copy library files into project. First, um, Okay, yeah, you have to first understand this, make rules for yourself to go slow, and do not implement anything of scale, of significant scale. Ask me for every decision, explain something very clearly. We're trying to learn here and get maximum understanding of the project. So keep that in mind. Keep this instruction Claude.md. So kind of putting some guardrails for Claude. Okay, all right. So for every, I believe for every session, Claude will load itself. I mean, Claude.md will load. So I think that's cool. Okay, that's cool. Now, before writing any code, one question. So the question is, you try to ingest txt or md or something else. This matters because chunking strategy differs. A plain text file chunks differently than structured markdown. Starting with plain text is simplest. Yeah, we'll start off with txt. We'll start off with txt. All right. Yeah, obviously we're gonna start off with txt. Markdown. I don't know how it is structured. I don't know the file format for markdown. Let alone txt actually. Okay. So give me some answer. Okay, so good. Now, before writing chunk.c, let me explain the concept so the code makes sense when you get there. Okay, that's cool. What is chunking? Where does it exist? GT small has a 512 token limit. Okay. You're gonna feed an entire document into it at once, so I split the document into smaller pieces, chunks, each of which fits within that limit. GT small has a 512 token limit. Okay, that's cool. Roughly 3 to 400 words. You're gonna feed an entire document into it at once. You split the document into smaller pieces, chunks, each of which fits within a limit. Okay, got it. When you use a query as what is X, you embed that query and compare it against every chunk. Okay, the most similar chunks get sent to tiny llama's context. Pretty simple. The two parameters of chunking: chunk size, how many characters per chunk; overlap, how many characters the next chunk reuses from the end of the previous one. Okay. So chunk size is the how many characters per chunk. How many characters per chunk? Okay. We're trying to make sense of that. Okay. So it's 512 bytes. So 512 characters, because one character is 1 byte. Okay. Overlap, how many characters the next chunk reuses from the end of the previous one. 64. How many characters the next chunk reuses from the end of the previous one. Okay. While I've considered this text split is at a hard boundary, chunk 1, the answer to the question is chunk 2, 42. Okay, that's cool. Nice. Overlap is needed. True. Chunk 1 and chunk 2 are both incomplete thoughts. With overlap, chunk 2 starts with the answer to the question is 42. It has context. That's nice. That is really smart. Like, that's pretty good. The simplest strategy was called. Okay, the simplest strategy. If I can, 1 second. Yeah, okay. Uh, Without overlap, chunk 1 and chunk 2 are both incomplete thoughts. With overlap, chunk 2 starts with the answer to the question is 42. Thus, context, the simplest strategy is for TXT files split on character count with overlap. Uh, okay. No sentence detection, no paragraph awareness, simple correcting, good enough to start. Okay, that's cool. Fiddle, overlap 64, 64, 64. Interesting. Okay. Okay. The last 64 bytes. Last 64 characters rather. And then the next 64 characters will be the overlap between two chunks. Okay, spread on character count with overlap, no sentence detection, no paragraph awareness, simple correct, good enough to start. That's good. One issue before we write anything. Should the chunk size be fixed in code as a constant? Simply easy to understand. Pass as a parameter runtime, more flexible, slightly more complexity. Okay, the chunk size should be a parameter, I think. Obviously, it should be parameter. So we can see how it is doing when the chunk size is different, and we can try to understand which is better. Good choice. Flexible and clean. Okay. Thank you, Claude. It always appreciates me. That's pretty cool. One more attestation before we write chunk.h. Okay. The function needs to return multiple chunks. In C, there are two common ways to do that. Option A, return an array of card star, pass count back via pointer. Okay. Array of pass count back. Simple caller gets an array of strings in a count. Each string is a malloc copy. I don't think. Just wanted a value instead of an output pointer. Yeah, it says option A is better. So we try to understand what option A is. So it is char pointer chunk text, one star pointer text. Okay, int chunk size, int overlap, int number of chunks. Okay. Okay, return needs to return multiple chunks. The function needs to return multiple chunks. So what are we trying to do? So we're trying to return multiple chunks, and call gets an array of strings and a count. Each string is a malloc copy. Gets an array of strings. Gets an array of strings. Yeah. Okay. So okay. Yeah. Okay. So when we pass the parameter to the function, it goes as a copy. Yes. So again, so it is just an array of strings and a count. Okay, each string is a malloc copy. So once you're in the function, it'll be a malloc copy. Yeah. Okay. Return a string that holds the array and count together. Okay, we can do this. Okay. First of all, what is a chunk? Um, what is a chunk? Okay, so a chunk is just a plain string char pointer. Okay, alright, okay. It's a string. Chunk is just a string, a piece of the original document text. That is cool. For example, if your document has Redis is in memory data structure stored, It supports strings, hashes, lists, and say, okay, that's fine. That's the text. And with chunk size 100 and overlap 20, you get chunk zeros will be that. So chunks 100. Okay, that's cool. And chunk will be that. Okay, that's cool. Each chunk is just a string, and it's special about the introduce part what happens after chunking. So pointer will be an array of strings. Cool. Yes, correct. Um, and that array of 384 floats. Okay, okay. Once again, each chunk is just a string. That is special about it. So Redis is and then okay, it will basically give you some number. We don't know this number yet. What is this score? I think it's the cosine similarity score, right? So no, it's not the cosine similarity score. We're not doing the user query as of now yet. We're just converting into score of the embedding, which I don't know what it is. That error 384 flipboard gets stored in compare. The chunk text itself is stored alongside it, so you can send it to Tiny Llama when it's retrieved. Okay, stored alongside it, so you can send. Okay, that's cool. So chunk in memory is two things together. The text, okay, that's sent to the LLM,